Hey all, we're back again. I had the question posed to me from Hannah. Hannah, thank you for asking me the question about number 6 from 9.3. So I might as well notate that. I forgot to say that right here. So unit 9.3 is where this comes out of. So what we're asked to do here is find the area of this trapezoid, and there's kind of a more complicated method to find, and it asks to leave it in simplest radical form. I'm actually going to work through a method where we get our decimal answer and we get a precise answer already. It's not necessarily as clean as radical form, but it comes out to be almost precisely exactly the same, and it's kind of more the skills that I'm really hoping that you guys hone into. So we've done a little bit of trig work already, and we've worked with sine, cosine, and tangent. So one of the first things that we want to do here is figure out what this angle A is, because the tricky part about this image is that this is 8 inches. I've got right angles here, so all these right angles show me that this vertical line is going to be parallel to this vertical line, so that helps me. But the one thing is, you're gonna want to say that this is a square. It's not a square. Your brain wants to say it's a square because it looks like it's a square, but all we know is that it's a rectangle because nothing tells me that all of these edge lengths are the same. What I do know is that since this is a 90 degree and this is a 90 degree intersection with my transversal at the bottom, then because my top edge is 8 inches, my bottom edge is 8 inches. And since I know that bottom edge is 8 inches and the entire length of that bottom edge is 18, that lets me know that this green edge right here, the leg of the triangle, is actually 10 inches. Because I can just take the difference of the 18, subtract away that 8 inches there, and find that this green edge is 10 inches. So I'm actually going to highlight that in green to make that a little bit more obvious. So the first thing we want to do, working towards finding this height, because if we're going to find the area, we're going to have to know the height, is to determine the degrees of this angle right in the corner, because from there we can use trig to help us solve for that height. So what I do is I set up the trig function for cosine, and I use cosine because when I think about what two sides do I have the side that's adjacent to the angle that I'm trying to solve, and I have the hypotenuse. So the hypotenuse never matters where it is relative to your angle that you're trying to solve. It's always going to be connected on one of the sides, because remember, hypotenuse is always across from the 90 degree. So if it's not the adjacent side, then it's going to be the hypotenuse, and we know it's across from the 90. So I set up that cosine of angle A is going to be adjacent over hypotenuse because I know my SOHCAHTOA, and then I fill in what I know. So cosine of A, which we don't know yet, is going to be that side of 10, my adjacent side right here, over my hypotenuse, which is 11. So then I set up my inverse trig, because in order to isolate the angle A, all I do is apply the inverse cosine to both sides. When I apply the inverse cosine to the left side, it cancels out that cosine. And when I apply the inverse cosine to the right side, it leaves me with my inverse cosine of 10 over 11. And when I type that on my calculator, making sure that your calculator is set to degrees as opposed to radians, that's going to give me the answer of 24.62 degrees for that angle. That's rounded just slightly, but if we go to the hundredths place, we're normally okay. So now that we have that degree measure, we can use that to solve for the height of my trapezoid. So to do that, I'm going to have to use a different trig identity. We can use either the hypotenuse or the adjacent. For me, I decided to use sine because sine is simpler, and when we get down to our proportion, you'll understand why, but the sine is always opposite over hypotenuse, and we plug in the angle that we're working with. So if it's sine of this angle, the opposite side is going to be my height, and the hypotenuse is still going to be that side that's 11. So then moving this down, sorry about that. So I have sine of 24.62. Then I put my h for my opposite side on top, and then I put the length of my hypotenuse of 11 on bottom. I'm just going to go ahead and get rid of that. And then we can cross multiply here. So if I take 11 times my sine of 24.62 and 1 times h, I get just h left on the right-hand side. On the left-hand side, I get 11 times. I got to use the asterisk for the times because it's a little hard to work with. And we don't want to use x for multiplication. So anytime you see that That asterisk used in mathematics, it's used to represent the multiplication. So when I do 11 times sine of 24.62, I'm going to get 4.58, and I should actually give that the label of inches because that is now the height right here. Tells me it's 4.58, and that proves to us that this is not a square. It looked like at the beginning it could have been a square, but now we've seen enough that we know it's not a square. So I'm actually probably going to drag this up just a little bit as we go. So let's just go ahead, and it'd be a lot to drag. So give me a sec. All right, so I got everything shifted, and it looks like we're okay now. So we know the length of our height, and we know that we can find the area of any trapezoid by averaging their bases. Sorry if I'm moving myself there. By averaging their base lengths and multiplying by the height. So, and we could break this up and we could find the area of the rectangle and then add it to the area of the triangle, but that's less efficient than just using what we know about finding area of trapezoids. So we know it's going to be the height times the average of the two bases, so base 1 plus base 2 divided by 2. So when I go ahead and plug in base 1 and base 2, I have base 1 was 8 on top and base 2 is 18. It's the entire base, remember? That becomes 26. I'm going to go ahead and delete this. So when I take 26 divided by 2, that gives me 13. When I take 4.58 times 13, I get 59.54 inches squared for the area of the entire trapezoid there. That's extremely close to our answer key. I think it had 13 radical 21 or something close to that. My recording software is kind of blocking me changing tabs. But it's really, really close to the area that you would have gotten taking the other method. If you want to see an example of the other method, we can do that in class together when we're back together on Tuesday. But really, this is the method that I'd like you guys to take so you understand how to work the trig to find the unknown lengths. And then using those unknown lengths, we can find the area of the whole thing. So Hannah, hopefully that helped. And hopefully for anybody else that was struggling with that, that helps you out there. Your final answer is approximately 59.54. If you have answers for these problems that are not in radical form, that's okay. If you put them in decimal form, I will be totally fine with that. There's a lot of right ways to get to Florida, many methods to solve these, so you guys are fine to have decimal answers there. Please keep letting me know if you have any questions, comments, or concerns about any of this work. I will try to get back to you as soon as possible. So keep working hard, and I'll see you guys soon. Alright guys, I felt bad leaving you with just the trigonometry method in case you're still not comfortable with trig, so I figured I'd cut back into this video and give you the other method for solving this problem. So if we're going to use the Pythagorean Theorem method, we actually don't care about angle A. So I'm going to go ahead and get rid of this and clean this up a little bit. All I really care about is finding the height of this triangle. So if you forget about everything to the left of this blue line here, all we have is a right triangle. And we know the hypotenuse and we know the leg. So I can set up the Pythagorean theorem and say that the hypotenuse squared is going to equal the sum of the two legs each squared first. So I'm going to take my leg on the bottom, 10 squared, and then my height squared. So what I do when I get that is 121 equals 100 plus h squared. I leave that squared till the very end. Take away that 100 from both sides to isolate the h squared. I then get that h squared is equal to 21, and that tells me that h is going to equal the square root of 21. From there, I take the same method for solving for the area of the trapezoid. I average the bases, which we already found earlier in the video. The average of those bases is 13, and that is how your answer key gets 13 square root or radical 21 as your answer, because instead of finding the height as the decimal value that we found earlier in the video, they just leave the height as square root of 21. So there's both methods for solving for this area problem.